Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
Now this is what we call coordinate geometry. That involves graphing and all that, okay? For instance, a graph has two axes. The vertical one is what we call the y. The horizontal one is what we call the x. The y has positive side going up, negative side going down. That is for y. So you have positive y and negative y, if you like. Did you get that? Also, the x has positive side going to the right and negative side going to the left. So you have positive x and negative x. I hope you're still listening. Okay, so if I dot a point here, for instance, the coordinate of this point is its position on x and its position on y. So let me call it point A. What is position on x and what is position on y? What's the position of this point I dotted here on x? And what is its position on y? Go ahead. What is the position of this point I dotted here on x? And then what is its position on y?
6 minus 6.
Okay, its position on x is 6, right? Now what about its position on y? You trace it to y to get its position on y.
Oh, on the opposite side. Oh, 4.
So the coordinate is 4, comma 6. You mentioned the x first and then the y.
Yeah, but the x was 6, so
Oh,
wouldn't
sorry,
6
I made a mistake. 6, comma y, 6, comma 4. 6, 6, comma 4. Because you mentioned x first and then y later. X, comma y. Okay, give me the coordinate of this point. I'm going to call it B. Give me the coordinate of this B.
13.
Okay,
Oh, no.
yeah, you're right.
13,
Comma,
9.
comma 9, that's correct. On x is on 13, on 13th, and then on y is on 9. Okay, give me the coordinate of this point. I'm going to call it C.
Minus 7, 3.
Minus 7, then comma 3. It's a minus 7 on x, that's here, and 3 on y. Okay, give me the coordinate of this point. I'm going to call it D.
0, 0, 0, 1.
I'm in here. It's 0 on x and 0 on y.
0, 0.
Okay, so that's 0, 0. 0, 0 is also called origin. Fine, maybe give me the coordinate of this point. I'm going to call it F.
Minus 6
Are you sure? Is it up to... Okay, yeah, minus 6
and minus 5.
And minus 5. That's fantastic. You just need to tell me something here, and I think we can look at this later. See this line? Line AB. Can you see line AB? There's something we call slope or gradient. Slope. or gradient of AB. This is how to get it. You do y2 minus y1 over x2 minus x1. It's easy. Very, very easy. Which is like rise over run. What I mean by rise over run, you do how much its height and then its width. See the height? So let me draw it again. The height against the width. That's rise over run. The height is rise. The width is run. So gradient, you can also call gradient as rise over run. Rise over run, right? So what it is height, what it is width for that line AB? You get the height here to here, and then the width here to here. So rise over run. What's the height?
The height is 13.9.
13.9. Good. Is it 13.9 the height? This is the. I mean the height is the distance from here to here. Watch. See the way what I'm doing.
Yeah.
That's 1, 2, 3, 4, 5. The 1, 2, 3, 4, 5. That's how high it is. Did you see that? 1, 2, 3, 4, 5.
Oh, 5.
What's the width?
5.9.
The width is 1, 2, 3, 4, 5, 6, 7.
Wait, I can't see you drawing.
Oh, okay. The internet, your internet is affecting it. Okay, but did you just see what I did now?
Yeah.
1, 2, 3, 4, 5, 6, 7.
Oh, I can't. 1, 2, 3, 4,
It's counting now.
7.
Did you see that?
That was. That was 8.
Is it up to 8? No, it's the space. 1, 2,
2.
3, 4, 5,
6.
6,
Oh.
7. 7 spaces.
Mhm.
So it's over 7. 5 over 7 is what we call the gradient or slope, and it's usually presented with m. So slope or gradient, or which is m, is 5 over 7. It's very easy. Can you do this one so that we will appreciate the work done? Let me see this one very quickly. Look at this. Let me draw this one. Okay, no, it looks a bit. It's going to affect that work. Let me do it separately. Let me do it differently. Let me do something like this. Just a moment. As it shown at your end, the blue line.
Yeah.
So you also do the rise over the run. So the gradient for this line, that line is what?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Is it 9? Let me confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes.
12, and then 9 to
That's
12.
9 over. That's for the rise. What's the run?
12.
1, 2, 3, 4, 5. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's correct. 9 over 12. Or you can say 3 over 4. That's a gradient. Rise over run. That's the simple way to do this. It's not difficult, okay? You can even do that by doing y2 minus y1 over x2 minus x1. What I simply mean is, like this one becomes y2. This one becomes, sorry, I didn't put it properly. This one becomes x2. This is x1. Oh my goodness. x2, y2. x1, y1. You will get the same answer. Finally, I just want to show you this. You will get the same answer if you do it like this. If you apply this formula, read it out. Read out what I circled.
Y2 minus y1 over x2 minus x1.
If you do that, you will get the same answer. What I mean is the one part you call it x2 and y2. The other part you call it x1 and y1. And just put their values. Like in this case, this y2, what would you have written here? For y2?
13.
No, see what is y2. See the one that represents y2.
9.
So I would have written 9 there. So you get the same answer. You see 9 minus. For y1, what would you have written for y1? See,
4.
4, yeah, exactly. So 9 minus 4. Now for x2, what would you have written for x2?
13.
13. What would you have written for x1?
6.
By the way, x2 is 13, x1 is 6. So it's 6. You would have written 6. Check, you will get the same answer. What is 9 minus 4?
What's what?
Check now, what's 9 minus 4?
5.
Is that not the same 5 we got? What is 13 minus 6?
7.
7. So the slope is still 5 over 7. If you do the same thing here, you will get the same answer. That's basically it. The only thing you need to know, need to know is if the line is sloping downwards like this, the slope will have a negative value. Did you see what I just showed here? Negative slope, because it's sloping downward, negative. But if it is sloping upwards like this, if the line is running up, climbing, it will have a positive slope. This one is positive slope. You know, plus is for positive, minus is negative. Do you know? Let me just, this is the very last thing I'm going to do, and then you see it. Watch this. I'm going to show you very, very quickly, and that's it. I said if the line is running down, like descending, the answer will carry a minus. If the line is going up, the answer will carry a plus. So just watch it. Let me show you. Let me show you with this one. Let me show you with this one. Are you ready? Okay. Let me show you with this one, and then that will be it. Show you with this one. This particular line now, what's the rise? Let's count.
1, 2, 3, 4,
1,
5.
2, 3, 4, 5. The rise is 5. The rise is 5. What's the run? Let's count the run. 1, 2, 3, 4, 5, 6, 7, 8, 9. The run is 9. So that means the slope will be.
Hello?
Yes, can you hear me? Yeah, the slope for that one will be 5 over 9. So slope here is. Did you hear me? Hello? The slope there will be 5 over 9. Slope will be 5 over 9, which is rise, the height over the run, 9. But we're going to add a minus because it's sloping downwards. You know, so it will have a minus. The slope is equal to. Can you see what I'm doing? Can you see what I'm doing? And of course, finally, this one, you will see how that plays out here. Let me show you this one. The same thing. This is it. You also have the rise 1, 2, 3, 4. Run 1, 2, 3, 4, 5. Okay, rise is 4. Run is 5. You know, so the slope for this other one will be, the slope is simply 4/5. That is going to have a plus because it is sloping upwards. If it is going down, I said it will carry a minus. If it is going up, it will carry a plus. The answer will have a plus. That's all. That's all. So like this one that is sloping up will carry a plus. A plus. If it is going down, a minus. So you just do rise over run and all that. So it says the line AB passes through point A and this point. The gradient of AB is 5. Work out the value of K. Alright. You know gradient is changing Y over changing X. So 5 is 6 minus K. Why did you say 6 minus K? Gradient is changing Y. Oh, see how a simple mistake like this can read so much.
Do it again.
Yeah, please be careful. I'm going to erase all of this. It's a beautiful, fantastic work you've done. Sorry, you don't have a choice. You have to erase all. So gradient 5 is equal to K minus what? You're making the mistake again.
Oh, wait.
Oh, no wonder. It's the way you expressed it. I can see. This is where you're running into a problem. A coordinate is x, y, not x, x. So this is actually x1, y1.
Oh.
Yes. And the other one is x2, y2. So that's where the problem started from.
So would it be K minus 1?
Exactly, K minus 1. So K minus 1. So 5, which is the gradient, is K minus 1. That's y2 minus y1 over x2 minus x1, which is 6 minus 2. That's correct. Okay, let me just use a different color for this thing. Next time when you're doing it, okay, so that it doesn't look like you're multiplying the denominator. Put it at the top, times 4 times 4. Are you serious? Okay, K plus 1, yes. because the 4 will cancel out this 4 when you multiply both sides from here. You multiply both sides by 4. Let me even write it down. Alright, so k is minus 1, k is 19.
Yeah.
Alright, that's cool. Both sides by 4, you have 20 equal to k plus 1. You subtract 1 from both sides, you have k is equal to 19. Okay. Okay, we have shown that gradient is y2 minus y1 over x2 minus x1, or rise over run. Another example, for instance, this green one, just a quick summary. This green one, gradient is y2 minus y1 over x2 minus x1, or rise over run. The rise is 10 spaces rise. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's count properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the rise. The run is 1, 2, 3, 4, 5, 6. So rise is 10, run is 6. So gradient is 10 over 6. And since it is sloping upwards, the gradient is positive. Remember, sloping upwards, gradient is positive. But if it is sloping downwards, gradient is negative. We could have also used changing y over changing x. In this case, we could do this first y, 4 minus these two coordinates, coordinate at A and coordinate at B. We could have done 4 minus minus 6 for the y, this y and this y, which is for changing y, over 3 minus minus 3. The value of y here minus the value of y here for changing y. The value of x here minus the value of x here for changing x. And that gives us 10 over 6, just like we got earlier. If we are used rise over run, it's the same value, we reduce to the lowest term, 5 over 3. Also for the yellow line, to summarize again, gradient, rise over run, start from any point and rise 1, 2, 3, 4, 5. Rise is 5, run is 1, 2, 3, 4, 5, 6, 7. So it's 5 over 7, and since it is sloping downwards, it is minus. So gradient is 5 rise, 7 run, and it's sloping downwards, so the gradient is negative. Remember, sloping upwards, gradient is positive. Sloping downwards, gradient is negative. Now, this is the general equation of a straight line, as we have said a number of times. Y equal to mx plus c. M stands for gradient or slope or tangent sometimes. It's called tangent too. Gradient or slope or tangent. YC stands for intercept. Remember, M stands for gradient or slope or tangent. C stands for intercept. The intercept is the y-intercept, where the graph cuts the y-axis. Some graphs will have a specific position where the graph cuts the y-axis. For the green graph, for instance, it cuts the y-axis at c equal to minus 1. So the intercept for the green graph, for this green graph, is -1. The intercept for this green one is -1. This position where it cuts the y-axis or the y-intercept. Now, if the intercept is not given or not obvious, like for this yellow line, we can actually use any particular coordinate, either E or D, and its gradient, -5/7, to find that intercept. We can choose any coordinate. It can be coordinate D or coordinate E, assuming we want to use coordinate D, which is 4 - 2. Coordinate D is 4 - 2. Since we already know that's for the yellow line, we already know its gradient as -5/7. Gradient is -5/7. That's M is -5/7. We can pick any coordinate. We can use coordinate D or coordinate E. Now let's use coordinate D. At D, which is 4 - 2, 4 - 2, we just apply the equation of a straight line, y equal to mx plus c. These 4 and -2 are the x and y coordinates respectively. This is the x. The first one mentioned is the x. The second one mentioned is the y. X and y coordinates, s comma y. Any coordinate we start first of all with x before y. S comma y. So at D, which is 4 - 2, 4 comma -2, y is -2. X is 4. We already know the gradient to be -5/7. We just substitute into these values. Y for -2, X for 4, then M for the gradient we found earlier, -5/7. So -2 is equal to, for y equal to mx plus c, we will say -2 is equal to -5/7 for m times 4 for x, then plus c that we're looking for. We just solve this equation to get c. So we solve this equation to get c. We solve this equation to get c. -2 is equal to -5/7 times 4, then plus c. -2 -4 times -5 times 4 will give us -20/7 plus c. So if we find c, c is simply, we move this to the other side, it becomes -2 plus 20/7. When -20/7 moves to the other side, it becomes plus. So -2 plus 20/7 will give us 6/7. So c is 6/7. The intercept is 6/7. The intercept for this yellow line is 6/7, especially when it is not given. We can use that to find it. All right, that's how to find an intercept, especially if it is not given. The c intercept, the c or y intercept. Just pick any coordinate, for instance D or E for any given line. If you pick D, the values given for x and y, substitute it into the general equation of a straight line, y equal to mx plus c. Y for x for -2, x for 4, and then also the gradient we found already, and then solve to find c. In this case, c is 6/7. Okay, so with that we can get, now assuming we want to confirm this c intercept here, which is for the green line. For the green line, we know that the c intercept, the y intercept, which is c, where it cuts the y axis, is equal to y equal to minus 1. That's minus 1 at this point. This is minus 1, this is minus 2, this is minus 3. This is minus 1, minus 2, minus 3, minus 4, minus 5, and so on. So C here is minus 1, or the y-intercept is minus 1 for the green line. But we can confirm by doing the same thing. We still write the equation of the straight line y equal to mx plus c, and pick any coordinate. For instance, we can use coordinate A, and we are looking at that the intercept of the green line. We use coordinate A. Coordinate A, we might want to use coordinate B. If you use coordinate B, you will get the same answer. If you use coordinate A, so long as it is on that line, you will get the same answer. So for coordinate A, which is 3, 4, coordinate A, which is 3, 4, let me write it, 3, 4, the 3 is for x, the 4 is for y. Again, we are substituting it into this equation, y equal to mx plus c. So y is 4, so 4 is equal to the gradient. We already find the gradient, which is m, as 5 over 3. So 5 over 3 times x, because it's mx. X is 3, so 5 over 3 times 3, then plus c. There's 3 down here, although we didn't need to do all this, but we can multiply all through by 3 to remove the fraction. Whenever you have a fraction in an equation, multiply all through by the LCM. The LCM is 3. So 4 times 3, this whole times 3, this whole term times 3, this whole term times 3, which is 3 times 3. So 4 times 3 will give us 12. This whole times 3, 3 will cancel out, that gives us 15. And then c times 3 gives us 3c. So 12 is equal to 15 plus 3c, or 3c is equal to 12 minus 15. If 15 crosses over to the other side, it's minus. So 12 minus 15 is 3c. In other words, 3c is minus 3, which also gives us c equal to minus 1. And that confirms the y-intercept of the green line. C is minus 1, where it cuts the y-axis. In fact, the y-intercept is the value of x. Is the value of y when x is 0. I'll say that again. This point is when x is 0, because that's the 0 position for x. And then whatever value of y when x is 0 is the intercept. For instance, this black one, the intercept is minus 6. Minus 6. And this is when x is 0. So when x is 0, y is minus 6 for the black line. For the blue line, the intercept is 2. So when x is 0, y is minus 2. The intercept is minus 2, sorry. When x is 0, y is minus 2. For the black line, the intercept is minus 6. When x is 0, y is minus 6. For the yellow line, we found the intercept. For the green line, the intercept is minus 1. When x is 0, y is minus 1. We found the yellow line to be 6 over 7. Rather, 6 over 7. For the yellow line, the intercept, where when x is 0, y is minus, is 6 over 7, positive. Okay, if we know the intercept, we can use the value of the intercept to get what we call the equation of the, we can use the intercept to get the equation of the line. We can find the equation of the straight line if we have the intercept. For instance, for this yellow one, we found the gradient to be minus 5 over 7. That's for the yellow line. That's the yellow line. We found the gradient to be minus 5 over 7. m is minus 5 over 7. And we found the intercept to be, for the yellow line, we found the intercept to be 6 over 7. C is 6 over 7. So the equation of the yellow line, equation of a straight line is always y equal to mx plus c. Y equal to mx plus c. So all we need to do is to rewrite this and substitute for m and for c. Substitute for m and for c. That's the essence of getting the intercept. After finding the gradient, the next thing is to get the intercept. Once we have the gradient and the intercept, we can write the equation of the straight line. If we have the gradient and the intercept, we can write the equation of the straight line. For the yellow line, the gradient is minus 5 over 7. Minus 5 over 7, and the intercept is 6 over 7. So we just substitute that here. So it becomes y equal to minus 5 over 7 for gradient m, then x. So minus 5 over 7x plus the intercept, which is 6 over 7. So the only thing we are substituting is gradient and intercept. Gradient and intercept. Gradient and intercept are the only two things we substitute. Minus 5 over 7x, just like mx, plus 6 over 7, just like c equal to 6 over 7. So y is equal to minus 5 over 7x plus 6 over 7. That's the equation of the straight, the yellow line, which is straight. For the green line, we know that the gradient is 5 over 3 for the green line. The gradient is 5 over 3, and we also have the intercept as minus 1. We also found the intercept c for the green line to be minus 1. Although that was already given, the intercept for the green line is minus 1. So we have the intercept minus 1. So we can also use this method to find the equation of a tangent at any given point. For instance, for this particular graph, we have this is also 1, 2, and so on. So this particular point, the coordinate of this point is 7, 2. Let's call this coordinate B. This point, 7, 2. 7 is its position on the x-axis. 2 is its position on the y-axis. So 7, 2. The tangent at this point is a line that is almost touching it, like this, which I will explain later in more details. A line that is touching this, it has to touch it properly. A tangent can be drawn this way, or it can even be better. This line, this green line, is a tangent. And this tangent is at point 2, 7. We can use that to find the equation of this tangent. Equation of this tangent. Equation of this tangent. What we just need is get the gradient, get this gradient or slope of this green line, just like we did for this green line. Get the slope. Slope is, gradient is y2 minus y1 over x2 minus x1, or rise over run. So for the line that we have drawn for the tangent, this line, this green line, we get the gradient, which will be from any point rise over run. Pick any given point, rise over run. After we've gotten the gradient, we can use this particular coordinate. For instance, 7, 2. like we did in the other one, the previous ones, like when we used 3, 4. After we have gotten the gradient m, we just substitute the x values and the y values with 3 and 4 respectively. 3 for x, 4 for y, and then the gradient we found, we use that to get the intercept c. So that's the same thing we can do here. This green line, we find the gradient of this green line. If we have found the gradient of that, after finding that, we use these coordinates 7, 2, just like 3, 4, and do all of these to help us find the intercept. And after we found the intercept, we can substitute both the gradient and the intercept into the equation of a straight line, like we did here. We substitute the gradient, 5/3, the intercept, -1 we got later, into the equation of the straight line, and that gives us the equation of that line. So the same thing here, find the gradient first, and then from the gradient, we have pick up that point 3, 7, 2, use that to find the intercept, and from the intercept we substitute the gradient and the intercept into the equation of the straight line. That's the equation. An example will introduce it. Okay. Let me say this properly, you will get it. It's very easy. Watch me. We found the gradient to be what again?
7.
Good. So we are plugging in all of this into this equation, general equation of a straight line. This is the general equation of a straight line, y equal to mx plus c. Have you not come across this before? Yeah, y equal to mx plus c is the general equation of a straight line. We are plugging in these values into the general equation of a straight line, and I said m stands for the gradient. M is the gradient, so we are representing m with 7. X, we use the value of x. What's the value of x there? 2. Y, we use the value of y there, 6. So let me write it down again. At 2, 6, let me see the way I can write it so I can show you this. When you are reading it, you understand with it. At 2, 6, remember the 6 will go to y, while the 2 goes to x. Substitute all of those values. So we're going to have, this gives 6 equals, y equals, so it becomes 6 equals, m is what?
7.
So 7 times x. X is what?
2.
X times 2 plus c. We don't know what c is, so we can just use this to find c. So 6 is equal to 14 plus c. What's c? 6 minus 14, which is minus 8. 6 minus 14 is 8. You can solve it in your own way. Just leave c here and take 14 across. It becomes 6 minus 14. It's minus 8. Am I right? Are you trying to see how you can solve this?
Yes, sir. Hold on a minute.
Yep. Okay.
Okay. Carry on, sir.
I should carry on?
Yes, sir.
Because if 14 crosses over, it becomes 6 minus 14. So c is minus 8. All we are trying to do is to get c. And once we've gotten c, we write out these values again, substituting m and c, leaving the rest. So I will just write the final thing. The equation of the tangent will now be equal to, it's going to be an equation. All other things will be written left the way it is. We're only going to substitute m and c. M and c. Y will still be y, x will still be x. Only m and c to get an equation. So y will be equal to, what did you get for m? I will run through this for you to understand again. What do you get for m? 7. Are you still there? 7x. What did you get for c? Minus 8. So this is the equation of the tangent. Okay, you said you still remember how I did this one to get the equation of the tangent. But I think what I'm saying is there's an easier equation you can use. Instead of having to find c, you first of all find c and then you substitute to get the main equation of the tangent. The simplest equation is this. Read it out. Read out the equation. Can you read out the equation?
Y minus y1 over x minus x1 is equals to m.
Is equal to m. The y1 and the x1 are the coordinates. In fact, that's the y1, x2 is the x1, 6 is the y1. So we just substitute them into this equation. 6 is the y1, 2 is the x1. Of course, the intercept is 7, You remember?
Yes, sir.
Okay, so we just substitute. Let's do the substitution again. Y is equal to y minus 6. Okay, let me write it with a black pen. Y minus 6 over x minus 2 is equal to 7. Am I right?
Yes.
It's like saying 7 over 1. So you cross multiply. Cross multiply. This times this. What is y minus 6 1?
Y minus 6.
Exactly, that will still give you y minus 6. So this is y minus 6 equal to, what will be 7 times this? That's like saying 7 open a bracket x minus 2. Is it not?
X minus 2. Yes, sir.
7 open a bracket x minus 2. That's 7 times this. So that gives us y minus 6 is equal to, open a bracket, you have 7x minus 14. So just simplify, because the general equation of a straight line is y equal to mx plus c. What I'm asking is simplify it so that you look like or simplify it in the form of the general, simplify it to the form of the general equation. Of a straight line. General equation of a straight line. Which is y equal to mx plus c. All you need to do is let y stay alone, or make y the set of formula. So y staying alone will now be y equal to, all this will go to the other side. Remember, I said just simplify this so that you look like this. So let y stay alone, make y the set of formula, y stays alone, every other thing goes to the other side. So you have 7x minus 14, then minus 6 crosses over, becomes
What? Plus 6.
plus 6. So that gives you what? Y equal to 7x minus 8. And that was the original, this first thing we got. So whichever method you use, you get the same answer. That was what we got initially. Y equal to 7x minus 8. That's the equation of the tangent. But I think this formula will be easier for you to remember. But you need to memorize it. Y minus y1 over x minus x1 equal to m.
Yes, sir.
Okay, I think that's cool. Okay. So this point is very important. Parallel lines have the same gradient, m. Now, if the gradient, the second point is if the gradient of line 1 is m1, and line 2 is perpendicular to line 1, and line 2 has a gradient of m2, then m1 times m2 will give you -1. I will explain. Okay?
Yeah.
Alright, let's see. Back to that graph, you may want to zoom in to 100 to full page so that you'll be seeing the graph. The graph together with everything. So the gradient of the green line. What's the gradient of the green line we found earlier?
5/3.
5/3. The gradient of the green line is 5/3. You know, 5/3 gradient rise over run, rise over run, 5/3, or use y2 minus y1 over x2 minus x1. We do not need to find the gradient of the black one if they are parallel. So long as they are parallel to each other, we do not need to find its gradient. Its gradient will also be 5/3 because parallel lines have the same gradient. Parallel lines have the same gradient. Gradient simply means steepness. If they are parallel, then they must have the same steepness. If they are parallel, that means they have the same steepness. So if that is the case, we can easily get the equation of the black line. So I will just write, if, by the way, this green line is what I called L1. I'm going to call this black line L2, L3, because I want to call something as L2. So L3 is parallel. L3 is parallel to L1. L3 is parallel to L1. That's the green line. The black line is parallel to the green line. Do you understand?
Yeah.
So they have the same gradient. That means M3 is also equal to M1. They have the same gradient, which is 5/3. Parallel lines have the same gradient. And since they have the same gradient, and we know the intercept, we can easily get the equation. What's the intercept of this black line? See where it passes the y-axis. Y-intercept is where it passes the y-axis. -6. So what's the equation of the black?
-6.
Excellent. So let's write the equation of the black line. Equation of black line. Equation of black.
Y equals 5. Y equals to 5/3x plus
So that's correct. Y equal to 5/3x, which is, you're using the general equation of a straight line.
minus.
Beautiful. General equation of a straight line, y equal to mx plus c. So that's simply y equal to 5/3x, because the gradient is 5/3. And so that's just y equal to 5/3x. The c is simply -6. We don't have to solve it all over again since we already have the gradient of the. Are you still there? Since we already have the gradient of the yellow line. All right. Once you have, since we already have the gradient of the green line, once you have the gradient of the green line as 5/3, we just use that same gradient because parallel lines have the same gradient, and substitute into the equation of a straight line, y equal to mx plus c. All we need is to change its intercept. So
So 5 over 3x minus 6. So if you notice, the equation of the green line is y equal to 5x minus 1. Let me even write it that with green. Y equal to 5x minus 1. Five x over 7 over 5 over 3x. 5 over 3x minus 1. While the equation of the black line is also something related to that. The only change is the intercept. 5 over 3x minus 6. So they all have 5 over 3x because they have the same gradient. The only change is the intercept. While this one has an intercept of minus 6, this other one has an intercept of minus 1. And if you check, the intercept of the green one is minus 1. I hope you are still there.
Yeah.
Okay. Now, if we have another line which is perpendicular to the green line, did you hear me?
Yes.
We have another line this time around. It is perpendicular to the green line. I'm going to draw it with blue. It's going to just be perpendicular to the green line. Let me see if I can use something like this. You know what perpendicular means?
90 degree. Right.
Yes. Okay, let me see. Yeah. This blue line, thank God that's the one I was using as M2, is L2. The blue line is L2 and it is perpendicular to the green line. Perpendicular means the angle between them is 90 degrees. The angle between them is 90 degrees. Angle between the lines, 90 degrees. So if two lines are perpendicular to each other, the product of their gradient will be minus 1. M1 for the gradient of the first one, M2 for the gradient of the second one. M1 times M2 will give you minus 1. Did you hear me?
Yeah.
Beautiful. So we can use that to find the equation of this blue line. We know its intercept. What's its intercept? Minus 2. I don't think we have enough space here, so we'll go to the next page and solve it. Go to the next page. Okay. So equation of this blue line. The green line, remind me of the gradient of the green line. Gradient of green line. Gradient of green line. Gradient of green line L1.
5 over 3.
Yeah.
5 over 3.
Yeah, I get you. 5 over 3. Gradient of green line L1, the gradient M is 5 over 3. M1 is 5 over 3. Now, blue line that's perpendicular to it, L2, perpendicular to it. I'm still on that page. The blue line L2, which is perpendicular to L1. We know that M1 times M2 is equal to minus 1. So we can use that to get M2. So M2 will be what? minus 1 over m1, which is simply minus 1 over 5 over 3. Alright, that gives us minus 1 over 5 over 3. And what would that give you? When you have 1 over something, just flip it so that you don't waste time. Flip the fraction. 1 over f and add minus to it since there's a minus. 1 over a fraction is just reciprocal of it. So please take note of what I just said. If you ask, find the reciprocal, what's the reciprocal of 5 over 3? 3 over 5. So you just add a minus to it. So that is minus 3 over 5. Okay, so we know the intercept of the blue line. What's the intercept again? The intercept of the blue line, I think, is minus 2. Minus 2. The intercept is minus 2. So we can easily get the equation of the blue line. So let's get the equation of the blue line. We know intercept of the blue line is minus 2. L2, the intercept C, or C2 if you like, is equal to minus 2. So give me the equation of the blue line.
Y equals to 5 over 3x minus 2.
Alright, equation of blue line 2, using the simple general equation of a straight line y equal to mx plus c, mx plus c will simply be y
equals to 5 over 3x minus 2.
Did you say 5 over 3x?
So it's 5 over 3 times x.
Are you serious? The gradient of the blue line is minus 3 over 5 from. The gradient of the blue line is minus 3 over 5. Did you remember?
Yeah.
The gradient of the blue line is minus 3 over 5. So that's what you are going to use for the gradient to replace m. It's no longer the gradient of the green line. It's the gradient of the blue line you are using. So give me the equation again. Y equal to minus 3 over 5x. C is minus 2, so minus 2. So this is the equation. This is the equation of the blue line. All right. Take note of this. We can use this in several ways. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234808509 5144 to learn more and get started today.